So page 9 in the journal. I don't particularly like their explanation of these horizontal and vertical translations, so I'm going to have you write them a little bit differently. If you like and understand the way they have it, you can go back and refer to that. But here's what I would like you to write, is what I have down here at the bottom. So I want you to write this, that f of x equals x plus h quantity squared. What that would do to our graph is shift it to the left h units. If we have something that is not in with the x, in other words, it's outside of the function, so it's an output. When we have a function like this, f of x equals x squared plus k, that's going to take that graph of x squared and shift it up k units. Just the highlighted parts, yes. Okay, I'll just give you a copy of mine when I'm finished, okay? Okay, for number 2, for the second thing, if we have f of x equals x minus h squared, okay, that's going to shift us to the right h units. If we have f of x equals x squared minus k, where it's outside of the parentheses, that's going to shift it down k units. And that stuff I feel like you guys did pretty well with on the quiz. So I think most of you understand the shifts left and right. But I would like you to jot this down. If I want to shift my function left h units, you want to think of x getting replaced with x plus h. So it's like wherever you see an x in the function, you're going to replace that x with x plus h to go to the left. It's exactly what we've been talking about. The left requires it to be a plus h. The replacement is x plus h. But if I want to shift my function down k units, I have to subtract k from the entire function. So we've talked about this before. When it's left and right, it's the opposite of what you would think. When it's outside of the parentheses, or in other words, it's out here by itself, it's going to do what you would think. It's going to take it up if it's plus, down if it's minus. All right. So let's take a function now. We've got some extra room here. Let's look at an example. And let's say that our function is, let's do negative parentheses x minus 4 quantity cubed plus 3. And let's say that we want to take that function up 5. I'll give you my notes, okay?
Hold on. It says left h units plus h.
Yep.
Wouldn't it be right?
No, it's the opposite when it's with the x. If we have x plus h inside the parentheses, that's going to shift us to the left. It's the opposite of what you would think. It's just like in the warm-ups, on number 2 in the warm-ups, that x minus 3 took us to the right 3 units.
How?
I'll talk about it more in just a few minutes, okay? So this is going to take us up. If we want to go up 5, what do I do with this function? I have to do what to it, everybody? Add 5 to it. So if I took this function and I turned it into, say, g of x equals, everything stays the same, but I'm going to do plus 5 more to this. That's the only thing that would change for me to go up 5. I don't change this in any way. I just change, when I add 5, it would just change that to a plus 8. Questions? All right. Let's go over to the next page. Okay, now we're going to look at reflections. This is already in your student journal. This is the way they describe it. And it's totally fine. What they're showing is, if you want a reflection in the x-axis, you multiply the entire function by -1. If you want a reflection in the y-axis, you replace the x with a -x. So I think you might want to write that down. Right here, to reflect over the x-axis, the entire function must get multiplied by -1. That's going to reflect us over the x-axis. To reflect over the y-axis, only the x gets replaced with -x. So when we want to do anything horizontally, a reflection over the y-axis, let me show you guys this. Let's say I have this parabola over here, and I reflect it over the y-axis. Can you see how that's really a change horizontally? When I reflect over the y-axis, that's changing it horizontally, isn't it? It didn't move it up or down, it actually moved it horizontally. So whenever we're doing anything horizontally, it's the x's that are getting affected. All right, let's look at an example now. So write a function, g, whose graph represents a reflection over the y-axis for this. So you guys, you don't have to write all that down. I just want you to write down what the answer would be. If I want a reflection of the y-axis for this, I want to know what would the function be to give me a reflection of the y-axis. Write it down in your book, and I want to know what you come up with. Nate, what do you think?
-x cubed plus 5.
He says it would be -x cubed plus 5. Does anyone have something different? Does anyone have this? Yeah, that's correct. Because wherever we have an x, we had to replace the x with a -x. But what's going to happen now if I cube this -x? It would just become -x cubed, right? So both of these are going to be correct. Questions on that?
I just remembered how it's, yeah, the parentheses plus, I just remembered.
Okay, good.
That's correct.
All right, so now we're going to write a function g whose graph represents a reflection over the x-axis. So now we want a reflection over the x-axis. Is that the same thing or not? Do we get the same answer? You guys try it on your own. How would I get a reflection over the x-axis now for that? Write down your answer. And then we're going to check your answer by looking at it on the graph. So our original function is x cubed plus 5. All right, so what do you think? Kushi, what do you think? -x cubed minus 5. So we're going to check it by graphing it. So we're supposed to have a reflection over the x-axis. Here's our original. And then here is what she said the answer should be. If I fold it over the x-axis, can you see how she is correct? That is a reflection over the x-axis. So her answer, she said, was -x cubed minus 5. And that would be correct. We had to multiply the entire function by -1. And that's how she got that answer, is multiplying the entire function by -1.
You just leave it at that.
You can. If you give me this answer, it's equivalent to that, so it's going to be correct. Guys, anytime you have something that's equivalent, I will always count it correct. I'm not big on having things written a certain way, because if it's correct, it's correct. It doesn't matter the form it's written in, unless it's specifically stated. Okay, horizontal stretches and shrinks. Here's the book's explanation. It's fine. To me, it's a little bit confusing. So I would prefer you just write this, and I think it will make more sense. If I want to have a horizontal stretch by a factor of 3, the x gets replaced with a 1/3 x. To have a horizontal stretch by a factor of 3, the x gets replaced with a 1/3 x.
How do you do, what equation you given up or not?
I'm going to show you one here in just a minute. So can you see what's happening there? What we're saying is, instead of using 3, we use 1/3 x. Okay? Remember how with horizontals, it's the opposite of what you would think. So when I'm saying that I want a horizontal stretch of 3, I use the reciprocal 1/3 x. So look at the next one. If I want to have a horizontal shrink by a factor of 1/2, the x would have to get replaced with a 2x. I have to use the reciprocal, because I do the opposite of what we would think for anything that's horizontal. Questions there? All right. So let's do a real quick example. Try to squeeze this in. Let me give you a fairly complicated function. Let's say that we have the function negative absolute value of x minus 2 plus 1. And we want to apply a horizontal stretch by 4. So I want to apply a horizontal stretch by a factor of 4.
So we should just write the equation?
You can just watch. You don't even have to write it. So I want you, what I would have to do here then is, wherever I have this x, I want to replace that x, not with a 4x, but with a what, everybody? 1/4. So it would be negative the absolute value of 1/4 x minus 2 plus 1. Now, I'm going to kind of go above and beyond here. This is pretty advanced. This is totally the right answer, totally correct. But I want to show you next year what they might expect you to do with that. They might say, within this parenthesis, factor out a 1/4. Just watch, you don't need to write. If I divide 1/4 x by a 4th, what do I get? Just x. What's 2 divided by 1/4? 8. 2 divided by 1/4 is 8. Look, 2 divided by 1/4. Can you see why that would be 8? Okay, so this would actually be an 8. And now I could take out, if it's multiplication, I can take out this number if it's multiplication. But not when it's subtraction, I'm not allowed to take anything out. So what that means is that this would actually be equivalent to negative 1/4 the absolute value of x minus 8 plus 1. These two things are equivalent. Something like this might be a bonus. It might be multiple choice. I would say, which of the following is equivalent to this? Let's say you go through and you think this is right. How could I check that it's right? Yeah.
That one votes.
Exactly. Graph this into y1, graph this into y2. If they look the same, then that's going to mean that they are the same function. And they will be. I'm not going to take the time to do that. Okay? So be aware of some things like that. Let's go on to the next page now. Vertical stretches and shrinks. The book does a pretty good job up here, but I just want you to add this on. Kind of separated for whatever reason. So to have a vertical stretch by a factor of 3, the entire function gets multiplied by 3. The verticals are easier because you just do what you would think you would do. You want a vertical stretch of 3? Multiply everything by 3. Easy enough. To have a vertical shrink by a factor of, say, 1/2, then the entire function gets multiplied by 1/2. Okay? Questions there? It's pretty straightforward with the verticals. I would much rather, if I were taking a quiz or a test, I'd rather see everything vertically rather than horizontally. Horizontally is kind of the opposite of what you would think. Okay, let's do an example now. I'm going to do this one with you. Write a function g whose graph represents a vertical stretch by a factor of 3 for this. I want you guys to be thinking about it. I want a vertical stretch by a factor of 3. So think about what you think it would be. You can jot it down if you want, or you can just tell me. Tyler, what do you think?
D equals 3 parentheses x plus 6.
Where do you want the parentheses to stop? After the 6?
After
After the x, and now plus 6? I agree. That would be fine. There are other answers, though. Anything else people were thinking? Do we have to have the parentheses there? No. So you could just have 3x squared plus 6. You could have this, though, as well. Can you see how that would be equivalent to that? So all those would be correct. All right, now let's do the tougher one. So same function, x squared plus 2, and now I want a horizontal stretch by a factor of 3. Try that on your own. Try to write that down in your journal. You want a horizontal stretch by a factor of 3.
Well, I know it's
Okay, Olivia, what do you think? Is this what you mean? I disagree. Kushi, what do you think? Nope, that's not right either. Abby, what do you think? That would be a correct answer. 1/3 x plus 2/3. No. That would not be correct either, now that I think about it. What do you think, Siddharth? That would be a correct answer. Yes. So this one is not correct. Now, I could make this one correct by doing this. Putting this in parentheses. This now makes it correct. The rule says if I want a horizontal stretch by a factor of 3, my x has to get replaced with a 1/3 x. So now do you see how if I put those parentheses in there, now it means something different? So it's 1/3 x in parentheses squared plus 2, or if I square the 1/3, it's 1/9 x squared plus 2. Okay? Yes?
In your second one, are you still supposed to have the square one?
Yeah, because it's 1/9 x squared. X is getting squared. 1/3 gets squared. So yeah. You were thinking the squared should be gone?
Yeah.
Because x is still, this is 1/3 is getting squared and x is getting squared. All right, guys, so down here in the practice, I'm going to do all the odds with you, and then you're going to go back and do the evens, and we're going to see how good you are. So let's look at this one. Translation 2 units to the left. Doing this with you. All that means is wherever I see an x, I have to replace that x with x plus 2. It's horizontal. I have to do the opposite of what I would think. X has to get replaced with x plus 2. This answer is correct, or this answer is correct, or this answer is correct. All three of those are correct. Most of you probably would have put this one, I would think, right? Is that what you would have done? This is the safest one because you didn't really do anything with it. You have to replace the x with x plus 2. This is not correct, and this is what a lot of people would put. Some of you might have been thinking that. That's not correct. The x must get replaced with x plus 2. That's not replacing with the x plus 2. That is not correct. All right, let's go down here to number 3. Translating 7 units down, all that means is I have to subtract 7 from this whole function, so g of x is going to equal negative 2x minus 5. Questions on that? That's probably one of the easier types. Okay, let's go over here. Number 5. I want a reflection in the y-axis. Can anyone tell me what to do to get a reflection in the y-axis? Go ahead, Brian.
You use -1 by f3 by the whole.
That would be for the x-axis. For the y-axis, I just want to do what,
I thought
Kush?
you were doing the x-axis.
Nope. Kushi?
Turn negative into, turn it to.
Right. All I have to do is one thing. Everything stays the same, but x is going to turn into negative x. Okay? So Ryan, just read it carefully. If that had said x, you would be correct. All right? Yep. Let's do a little more with it. Were you going to do some more with it?
I was thinking, could you get rid of the negative and get rid of the absolute value?
Yep.
4 plus x minus 1.
Yes, that's very good. What he's saying is I could factor that -1 out of there. Now I'm allowed to take the absolute value of -1, and I would actually end up getting this. This is the more advanced answer, that if you try to do that and get it right, I'd give you an extra point. These two are equivalent. See how they don't really look equivalent? But they are. If we graph these two, they're going to be the same thing. This is absolute value, not 11. Okay, let's go down to number...
On 1.
Yeah, but that's not the correct symbol. Okay, so for number 7, we want a vertical stretch by a factor of 4. Morgan, can you tell me what I would do?
Yeah, put it before
On the outside, and then just put everything else in parentheses? That would work. That's the easiest way to do it. The more advanced way to do it would be this. Okay? Everybody see why they're equivalent?
Would you use that?
No, because that's not hard to do. Number 9. Horizontal shrink by a factor of 1/4. This is where it gets tricky. We see horizontal. We have to do something with it. Okay, let's get some new people involved here. James, can you tell me what I would do?
Wouldn't you replace x with 4x?
You are correct. So it's going to turn into this. And so my answer would now be this. Okay. Now I can take the absolute value of 32 since it's multiplication, and I can even make it this. That would not be a bonus point because that was not that difficult to do. But the ones where you have absolute value, like all this stuff, this is the tough stuff here. Okay, guys, so I want you to now try to do the evens on your own. You can talk to your partner if you need to.
I already did.